Coursera, Machine Learning by Andrew Ng. This course covers the basics of machine learning, including supervised learning, unsupervised learning, and best practices in machine learning. Deep Learning Specialization by Andrew Ng. This specialization covers deep learning techniques and applications, including neural networks, convolutional networks, recurrent networks, and sequence models. IDX, Artificial Intelligence, AI by Columbia University. This course covers the foundations of AI, including search algorithms, knowledge representation, logic, and planning. Deep Learning by IBM. This course covers deep learning techniques, including neural networks, convolutional networks, recurrent networks, and generative adversarial networks. Udacite, Machine Learning, Engineer Nano Degree. This program covers topics such as supervised learning, unsupervised learning, reinforcement learning, and deep learning. Deep Learning. Nano Degree. This program focuses specifically on deep learning techniques and applications, including convolutional networks, recurrent networks, and generative adversarial networks. MIT OpenCourseware. Introduction to Deep Learning. This course covers the basics of deep learning, including neural networks, backpropagation, and optimization techniques. Artificial General Intelligence. This course explores the concept of artificial general intelligence, AGI, and the challenges involved in creating intelligent systems. Stanford Online, CS231, Convolutional Neural Networks for Visual Recognition. This course covers convolutional neural networks, CNNs, and their applications in computer vision tasks. CS224N, Natural Language Processing with Deep Learning. This course covers natural language processing, NLP techniques, including recurrent neural networks, RNNs, long short-term memory networks, LSTMs, and attention mechanisms. Google AI, Machine Learning Crash Course. This course provides a practical introduction to machine learning concepts and techniques, including supervised learning, unsupervised learning, and neural networks. Microsoft AI, Microsoft Certified, Azure AI Engineer Associate. This certification validates expertise in designing and implementing AI solutions on Microsoft Azure. IBM AI, IBM AI Engineering Professional Certificate. This certificate program covers AI engineering principles and techniques, including machine learning, deep learning, and natural language processing. Amazon Web Services, AWS. AWS, Certified Machine Learning, Specialty. This certification validates expertise in designing, implementing, and maintaining machine learning solutions on AWS. DataCamp, Machine Learning Track. This track covers essential machine learning concepts and techniques using Python and R programming languages. These are just a few examples of the many AI certifications and courses available online. When choosing a course or certification, consider factors such as your current level of expertise, your learning goals, and the reputation of the institution or platform offering the course. Additionally, be sure to explore hands-on projects and real-world applications to reinforce your learning and gain practical experience in AI. When learning AI, there are several important aspects to consider to ensure you have a comprehensive understanding of the field and are well-equipped to apply AI techniques effectively. Here are some key considerations and important aspects to keep in mind. Foundational knowledge, understanding of mathematics and statistics. Concepts such as linear algebra, calculus, probability, and statistics form the foundation of many AI algorithms. Programming skills. Proficiency in programming languages commonly used in AI, such as Python, R, and Java, is essential for implementing algorithms and working with AI libraries and frameworks. Core concepts. Machine learning. Familiarity with machine learning algorithms and techniques, including supervised learning, unsupervised learning, reinforcement learning, and deep learning. Data. Pre-processing. Knowledge of techniques for data cleaning, feature scaling, feature engineering, and handling missing data, which are crucial for preparing data for AI models. Model evaluation and selection. Understanding of metrics and techniques for evaluating the performance of AI models and selecting the most appropriate model for a given task. Algorithms and techniques. Supervised learning. Understanding of algorithms such as linear regression, logistic regression, decision trees, support vector machines, SVMs, and ensemble methods. Unsupervised. Learning, familiarity with algorithms such as clustering, e.g. k-means, hierarchical clustering, and dimensionality reduction techniques, e.g. principal component analysis, t-distributed stochastic neighbor embedding. Deep learning, knowledge of artificial neural networks, convolutional neural networks, CNNs, recurrent neural networks, RNNs, and advanced architectures for tasks such as image recognition, natural language processing, and sequence generation. Problem-solving skills, ability to formulate AI problems, identifying and defining AI problems in a way that can be addressed using machine learning and other AI techniques. Creative problem-solving, thinking critically and creatively to design innovative solutions and adapt AI techniques to new and challenging problems. Ethical and societal implications. Awareness of ethical considerations. Understanding the ethical implications of AI technologies, including issues related to fairness, bias, privacy, transparency, and accountability. Consideration of societal impact. Considering the broader societal implications of AI applications, including their potential to exacerbate existing inequalities or address pressing social challenges. Practical experience. Hands-on projects. Engaging in practical projects and exercises to apply AI techniques to real-world problems, gain experience with AI tools and frameworks, and develop a portfolio of work. Collaboration and community involvement. Participating in AI communities, forums, and collaborative projects to learn from others, share knowledge and experiences, and stay updated on the latest developments in the field. By considering these aspects and focusing on building a strong foundation of knowledge, mastering core concepts and techniques, developing problem-solving skills, and staying mindful of ethical and societal considerations, you can effectively learn AI and become proficient in applying AI techniques to address diverse challenges and opportunities.